We're going to finish up the study of exponents by dealing with rational exponents. A radical symbol is used to indicate roots. The index is the little number right here that's on the radical symbol. So, for example, when you see this, this is saying you want a cubic root. So you're basically saying what to the third power will give you 8, and in this case it would be 2. Another way to write the nth root or a root is by using a fractional exponent. If your b value is greater than 1, b is what you're trying to take the square root of, then the square root of b is equal to b to the, in this case, 1/2 power. That's what it means, okay? So the 1/2, the exponent 1/2 is the same thing as saying square root, and that's because that's an understood 2 in there. This is just a little explanation that shows how that works. If we just say the square root of b is equal to b to the k power, k being a variable, and we go to solve that, we can square both sides, which the square and the square root cancel out. That's telling you that b to the first is equal to, we multiply these together, b to the 2k. Now, based on that, we know that these two exponents have to be the same. That's what this is saying. Those two exponents have to be the same. So if we're trying to solve for k, k would have to be 1/2. All right? We're going to use these. So again, there's a little helpful hint. When b is equal to 0, what is the nth root of 0? What is the square root of 0? What is the cube root of 0? What is the fifth root of 0? It's always 0. The same is true when b is equal to 1, when you're trying to find a root of 1. The square root of 1 is 1. The fifth root of 1 is 1. The 100th root of 1 is 1. Really quick question. Why is it that b has to be greater than or equal to 0? You need to know that. A number raised to the 1/nth power is equal to the nth root of that number. So, again, if you have a 1/3 power, that's the equivalent of asking for the cube root. If you have a 1/8 power, then that's the equivalent of looking for the 8th root. Do you see how those are the same thing? That's what this is telling you. So let's try some. So this is actually the same thing as the cube root of 343, which you can do on your calculator, which would be equal to 7. Now in this next one, we have addition. Our order of operations still holds true. You have to take care of the exponents before you can do addition. So this is basically asking you for the 5th root of 32. So what to the 5th power will give you 32? That's going to be 2. This one is asking you for the square root of 9. The square root of 9 is 3. So this problem in reality is 2 plus 3, which is 5. Okay? So don't let this scare you. Then we're asking for the 5th root of 81. And again, you can do this on your calculator. You can put it in your calculator like this, or you can put 81 raised to the 1/5 power, and it's going to give you the same thing. Okay, there is not an exact 5th root of 81, so on our calculators, it tells us that it is approximately 2.4, which is perfectly acceptable. Okay, a fractional exponent can have a numerator other than 1. So you'll see this right here, b to the 2/3 power, because it actually is doing two things. You can write it as a product in two different ways. You can say this top part is an exponent, the bottom is a root. So I can write it b to the 1/3 times 2, or I can write it b to the 2nd times 1/3. When you multiply these two together, you get 2/3. When you multiply these two together, you get 2/3. So they both do exactly the same thing. You can also rewrite it by taking the index down here and putting it in front of the radical sign. Okay? So either one of those does the exact same thing. And we're going to play with that, okay? This just tells you that a number raised to the m over n is equal to the nth root of the number raised to the mth power. Okay, so 8 to the 2/3 is the same thing as saying 8 to the 1/3 power, or the cube root of 8 squared. Do whatever's easier first. Or you could say 8 squared and ask for the cube root of that. Again, I tend to like to take the root first, especially if it has one. The cube root of 8 is 2, so this is the same thing as 2 to the 2nd power, which is 4. If you did this one, it would be 8 squared, which is 64, and then the cube root of 64 is also 4. All right? Here's a little chart just to help you remember some things. When you take the square root of something, we indicate that it's a non-negative square root. Okay? We just automatically assume it's the positive root. We can't just do that. So what we have to do is, when we can't really say for sure that it is positive, we put it in absolute value to basically say this has to be a positive number. This just lets you know, when you take a positive number to an even power, your answer is always positive. Okay, therefore, when you take the square root of it, or the root of it, any root of it, it needs to be positive. When you take a negative number to an even power, it's going to be positive. Therefore, when you take the nth root of that positive value, it's going to be positive. So we have to let it know that it's going to be positive. Okay? That's why we use the absolute value. If you take a positive number to an odd power, then it's going to be positive, because a positive times a positive times a positive is positive. And again, if you're taking an odd root of it, it needs to be positive. If you take a negative number to an odd power, then it's going to be negative. Now, this is when you'll have a negative underneath the radical sign. And the only time that you can do that is when you're taking an odd root. So a third root, or a fifth root, or something like that. This just summarizes it. It basically says when n is even, when you're taking an even root, then you have to use the absolute value. When you're taking an odd root, you don't have to use the absolute value. Or if the directions say all variables represent non-negative numbers, they're just taking that off the table right then. They're putting it out there saying to you, you don't have to worry about the absolute value. All right, let's try some of these. Ready? This is the 4th root of a to the 4th, b to the 20th. Now let me show you. If you rewrite this as a to the 4th, b to the 20th, taken to the 1/4 power, because that's what that radical with an index of 4 means, you can apply the rules that we've learned for exponents, which says this exponent right here is going to go to this, which is a to the 4th, taken to the 1/4 power, multiply the exponents, that gives you a. This is going to be b to the 20th, taken to the 1/4 power. Again, multiply the exponents, it gives you b to the 5th. See how easy that is? And basically what you're doing is you're dividing this number by the index. 4 divided by 4 is 1. 20 divided by 4 is 5. That's what you're doing. Okay? So here, you can do it several different ways. You can apply this. 6 times 1/2 is x to the 3rd. Y to the 4th times 1/2. 4 times 1/2 is y squared. This is the square root of y squared. Another little trick to learn is that a square root and a square cancel each other out, so that's a y. Clean this up by putting these y's together, and you get x cubed, y cubed. Now again, as we go along, these get progressively more difficult. Take it piece by piece. Let's take this 2. Let's give it to the x and make it x squared. Let's give it to the y to the 1/2 power. 1/2 times 2 is 1, and that's a y. And then down on the bottom here, the 5th root of x to the 5th, since this is an exponent of 5 and this is a root of 5, they cancel out, and that leaves you with an x. We're almost finished. We need to clean this up. We don't leave the same base number in the top and the bottom. So x squared divided by x is x. So that whole big thing there turns into just a simple xy. That's it.